Hello everyone and welcome to AWS Serverless Labs. Today we're going to be looking at AWS Lambda and Amazon SQS. So SQS, it's a queuing service that's provided by AWS, and the nice thing about it is that it's fully managed, so you don't have to worry about provisioning servers. You don't have to worry about scaling up and down. All of that, it's automatically handled by the service. And on the other side, we have Lambda, which basically allows you to run your functions, your code, also without having to worry about servers and stuff. So today we're going to look at how you can integrate these two services, how you can add the SQS queue as a trigger to your Lambda function. We'll look at the CloudWatch metrics, CloudWatch logs, and permissions, and some of the things that you need to take into consideration when working with these two services. Okay, let us get started. So to get started, I'm going to create a Lambda function. I just click on that Lambda there. You can also search for Lambda on the services. Okay, we only have one Lambda function in this region. Let us create a new function for this lab, and then I'll select use a blueprint because I don't want to write the code from scratch. And let's just search for SQS here. We have one blueprint for SQS Polar written in Node.js. Let's click on that. Okay, let's give it a name. Let's call it SQS my function. And then we are required to specify an execution role. An execution role is basically what the Lambda function assumes, the permissions that the Lambda function assumes when it executes. So those permissions will then be used by the function in order to interact with other services. For example, in our case, we want the Lambda function to communicate with the SQS queue. Therefore, the execution role must include permission to read and delete messages from the queue. So if you are working with S3 or SNS, likewise, you need to ensure that your execution role has the necessary permission so that it can communicate with those services. If it doesn't, you're going to receive an access denied error. So in our case, we're going to create a new role from AWS policy templates. You can select an existing role if you already have a role that can be assumed by a Lambda function. But in this case, we'll just create a new role and then let's give it a name. So we're going to give it a name. Let's use our function name. Just suffix it by role. As you can see here, it already attached a policy document. A policy document is basically where you write all the permissions that the role should have. So in this case, it already attached one for us, and that's because we selected a blueprint. So Lambda already knows that in order to use that blueprint, in order to have a SQS queue as a trigger to a Lambda function, at minimum, you need the permission to interact with a queue. So it already attached those permissions for us here. We're going to look at these permissions also later on. And in the next section, we have SQS trigger. So basically, this is where you specify the queue name, you specify the batch size, the batch window. But we're not going to do this now because we haven't created the queue. So I'll just remove this for now and we're going to create it later. And here we have the code. As you can see, the code is basically just printing out the message ID from SQS and the body. And yeah, it's not doing anything interesting. So let's create our function. Okay, so our function has been created successfully now, which is good. You can see our code, you can see our function name, the function ARN. So we're gonna need to add a new trigger here. But before we do that, let's look at the permission. So if you go to configuration, you go to permissions. So here you will notice that there are two set or type of permissions. So you have the resource-based policy and you have the execution role. So the execution role, like I said, it's basically the permissions that Lambda will assume when it's running so that it can interact or communicate with other AWS services. So if you want your Lambda function to talk to S3, to SNS, this is where you put those permissions. Then we also have the resource-based policy. It used to be called access policy. So on the resource-based policy, basically this is where you are now giving other services the permissions to invoke or trigger your Lambda function. For example, if you wanted an SNS to trigger your Lambda function, then you would need to add those permissions here to give the SNS service the permission to invoke, to trigger your Lambda function. So these are two different permissions. Anyway, let's go back to our code and we are going to now create our queue so that we can add it as a trigger. So to do that, let's search for SQS. We are now on the Amazon SQS management console. We are going to create a new queue. There are two types of queue on SQS. You can either have a FIFO queue where the messages are strictly ordered, or you can have the standard queue. So we're gonna use the standard queue for this experiment. And the name of the queue, let's just give it the name of the Lambda function. I'm not gonna change any settings here. We'll probably look at some of these settings in our upcoming videos, but for now we're just gonna leave everything as default. We have the access policy here. Gonna leave everything as default. Let's create our queue. Nice. That's quick to create a queue. Now our queue is created. We can start interacting with the queue. We can start sending messages and receiving messages from the queue, which is great for us. So now we are going to add this queue as a trigger to our Lambda function so that when a message is sent to the queue, it can invoke our Lambda function automatically. So let's go back to Lambda. Let's just copy the name of our queue because we're gonna need this. And then we're going to add trigger. We're gonna say SQS. Now we need to specify the queue name. Let's just paste the queue the name that we copied from the SQS management console. And now there are two other attributes that we need to specify here. We have the batch size. The batch size, as it says here, that it's the maximum number of messages to retrieve in a single batch. Take note, as the maximum, you might not always get 10 messages, especially if you have low number of messages in your queue. I would say less than 1,000 messages in your queue. You're more likely not to always get these 10 that's specified here. And then we also have the batch window. Now the batch window only comes into play if you want to create, if you want to increase your batch size to a number that's greater than 10. So basically that's what the documentation says. So if, for example, you want a batch size of 100, then you need to increase the time here, or the batch window, in order to give Lambda enough time to poll, to collect all those messages before invoking your Lambda function. So, but for this experiment, we're just going to leave everything as default. And here, this signifies that the trigger will be enabled as soon as we add it. So what's happening in the background is the Lambda service is basically provisioning Lambda pollers so that the pollers can read messages from the queue. And that's another thing that's different between SQS and SAY and SNS, is that SQS uses what is known as an event source trigger, in that Lambda provision workers or pollers that continuously poll the queue for new messages. So the new messages when new messages come into the queue, then those pollers will read the messages using the receive message API call and then invoke your Lambda function. Whereas on the other side, you have services such as S3 and SNS. Those services push messages to SQS, to Lambda, whereas SQS pull. In the case of SQS, the messages are being pulled by Lambda. So SNS would invoke the function. It would push those messages to the Lambda function. So in this case, there are Lambda workers that are always listening for new messages in the queue. So that's one thing to just note when you're working with SQS. So in our case now, our trigger is enabled and it's running. So we are going to go back now to our SQS and test if indeed this is working. To do so, we are going to send a test message. Going to send a test message into our queue. We're not gonna change anything here. Okay, our message has been sent successfully into our queue. So from the Lambda side, we're going to look at the logs to confirm that indeed those messages ended up invoking the message that we just sent in our queue ended up invoking our Lambda function. We can also look at the Lambda metrics. Specifically, we can look at the invocation metric. That would give us maybe a data point if the Lambda function was invoked. But for now, because I also want to see the message that invoked the Lambda function, I would like us to just look at the logs. So we're going to click on view CloudWatch logs, which should take us to CloudWatch, and that's where we are going to analyze our function logs. Okay, as you can see here, we have a log stream which says that our Lambda function was invoked. Let's click on that and see what is written into the logs. You can see here we have the message that we sent. This is the message ID, and we have the message body, which is test message, which is what we specified when we were sending the message from SQS. So we can see now that our integration is working, which is good. So now let us go back to SQS, and I just want to point out some of the things that you need to be aware of when you are working with SQS and Lambda. So one thing to be aware of is the default visibility timeout setting, or the visibility timeout setting. So basically the visibility timeout, this is on SQS. The visibility timeout is the number of time that SQS locks in messages or hides messages while they are being processed. So what happens is when you send a message into the queue, that message becomes available immediately, meaning that any consumer that's listening for messages from that queue can read and process that message. As soon as that message is picked up by one of the consumers, SQS will hide or will lock in that message so that it's not processed by other consumers while it is being processed by one of the consumers. So this is to try and avoid duplicate processing. And the time, the duration, or the total duration in which that message will be hidden or logged from other consumers depends on the time that you set here, which is known as the visibility timeout. So when a message is picked up from the queue, it becomes invisible. So now it becomes invisible. So now we have the visibility timeout set to 30 seconds. Yes, we have, that's the default one. And another thing to note is that the documentation recommends that you set this value to at least 6 times the function timeout. So in our case, since we didn't configure that, it's probably still the default. The default function timeout is 3 seconds. So meaning that it's 3 times 6. So that's what the documentation recommends. And the extra time or the additional time really is to try and give Lambda enough time to retry failed request. So for example, suppose now that the Lambda poller picks up messages from the queue, and when it tries to invoke your Lambda function, it gets throttled. So in that case, if there is still enough time left on the visibility timeout, what Lambda is going to do is it's going to retry those events. It's going to try to invoke your Lambda function again, say maybe after 2 seconds or 3 seconds or so. However, if you don't have enough time remaining on the visibility timeout, Lambda is not going to perform those retries, and the message will basically be put back into the queue and will be picked up again once it becomes available, which is going to be after the visibility timeout that you would have configured. So that's very important to note. And another thing that maybe we should look at now is what happens in the case when your Lambda function is not able to process a message. What happens in that case? What happens to those messages? Maybe there is errors, there are errors in the code, or the function gets throttled. What happens to those messages? So let's see what's going to happen in those cases. Let's go back to our Lambda function and let's break our Lambda function such that we can get an error when the function runs. So you can see already our ID is complaining here, but let's ignore that. Now we have redeployed our Lambda function. Let's go back to our SQS queue. And before we send a new message, let me just show you that we don't have any messages right now in the queue. You can do this by polling for messages. And you will see that there are no messages in the queue. Why? Because Lambda service deleted those messages after our function ran successfully. So that's another thing to note when you're working with SQS and Lambda, is that Lambda will only delete those messages from the queue when the Lambda function runs successfully, which is a benefit because you don't have to add that logic into your code, the same as the logic to poll for messages from the queue. I have seen instances where some users would write the code to poll for messages from SQS inside their Lambda function, and basically you end up having a situation where you are double polling because your code is polling and the Lambda pollers are also doing the same work. So you might run into issues there. So now, as you can see, we don't have any messages available. So let's send a new message into the queue and see what happens to that message since our Lambda function is broken. Let's just say test error, send message. Okay, our message has been sent to the queue. Now let's go back to our logs and see if our Lambda function was invoked. Okay, let's resume here. We're not going to find anything here. Why? Because we made changes to our Lambda function. So when you do that, Lambda will now provision a new container for the next invocation, which you can also see from the log stream. So basically each log stream would represent a unique container. Okay, let's click on this one. So as you can see here, we are having some errors, and you might ask yourself why so many errors. As you can see, it has ran 1, 2. I think if we keep on refreshing this, we might see this number growing. And the reason for this is that, yeah, as you can see, the number of errors are growing. So what's happening in the background is Lambda pollers are reading messages from the queue, the only message that's currently in the queue, and then they are invoking the Lambda function. However, when the Lambda function runs, it results in a syntax error. And because there was an error on the Lambda function, Lambda is not able to delete that message from the queue. So what happens is after that message goes back to the queue. However, it's not immediately available. It only becomes available after the duration of the visibility timeout, which is after 30 seconds. So that's basically what's happening here. So the message goes back to the queue, and then for that duration of 30 seconds, the message is invisible, and then after 30 seconds it becomes available again. And because the Lambda pollers are continuously polling for new messages from the queue, then they pick up the same message again and again and again, and this will basically go on for the duration of the retention period set on the message. So if you go back to on the queue, rather not message, if you go back to the queue and check the queue attribute, you'll see there's something there's what is called the message retention period. The default is 4 days. So in my case, if I leave this setup like this, the Lambda function will continuously pick that same message after every 30 seconds for 4 days until the message expires. So the message retention period can be set to a maximum of, I believe it's 14 days, but like I said, the default one is 4 days. So that's another thing to be mindful of, is that if a message is not successfully processed, what's going to happen is the message would go back to the queue and it will be picked up again. So now there is a way to avoid the message being processed multiple times. You can add what is known as a dead letter queue, which we are going to do now. So basically, a dead letter queue, you create another queue and then you tell SQS to say, look, if this message is not processed after 3 attempts, please remove it from this queue and send it to another queue. So at least in that queue, you can go and inspect it and check why the message was not processed without losing the message. So we're going to do that now. Let's go back to queues and create a new queue. Let's create queue. For the dead letter queue, since we use the standard queue for our main queue, we must use also a standard queue for our dead letter queue. So let's do this and say DL queue. Again, we're going to leave everything else as default. Let's create queue. So now we have our dead letter queue here. Let's go back to our main queue so that we can configure our dead letter queue. So let's search for our queue here. There we go. So we have our queue here and we can go to dead letter queue to configure a dead letter queue. Let's scroll down and you do that by specifying or enabling dead letter queue. So let's enable it and then let's specify our queue. Let's look for our queue here. Let's see if we can find it using this. Okay, there is our queue. And then we have property here called maximum receives. This is basically where you are telling SQS when should the message be removed from the main queue and be sent to the other queue. So in this case it's 10. So that means that after 10 attempts, that message will be removed from the main queue and sent to the other queue. In our case, since our message probably has been read more than 10 times now, as soon as we add this, that message will immediately go into our dead letter queue, and we'll see that now. Let's click save. Okay, so we have a dead letter queue configured on our main queue. If we go to our dead letter queue now, we'll probably see that message. If we start to poll for messages, as you can see, this is our message now. It has been removed. This is our test error message. It has been removed from our main message and is sent to our dead letter queue. So this functionality is very important to try and isolate the messages that are causing trouble in your workflow without affecting the other messages. So what we have done is we added our dead letter queue to our main queue and told SQS to remove this message after 10 attempts. So you can see here, they even show you the number of receive count. So this is the number of times this message has been received up until now. So this message has been received 13 times now, and this includes the number of messages times this message was received while still in the main queue. The same is true with the send time. So this basically indicates when the messages was first sent into SQS in the main queue. So it's not the time in which this message came into the dead letter queue. So that's a nice feature to have. Okay, so now we have looked at how to set up the trigger. We have looked at permissions. We have looked at how to handle errors. Now let us look at how you can monitor this integration. So to do so, let's go first to our SQS, and we're just gonna look at some of our metrics. So let's go to monitoring. So under monitoring, you can see a number of metrics here, and let's go directly to CloudWatch to make things easier so that we can overlay some other Lambda metrics as well to make it more interesting. So let's go view in metrics, which should take us to CloudWatch. And maybe let's add more. Let's send more messages to our queue so that we can have more data points to look at. You can just search for CloudWatch and go to all metrics. Maybe let's not do it this way. You can go to all metrics, and once you are here, you can search for SQS, and you can basically search for your queue here. So let's do this. There we go. We have 18 metrics related to our queue. So now we have, let's start with the number of messages sent. It's possible that the ones that we just sent now haven't updated, but basically the number of messages sent, it's the number of messages that have been sent into the queue, not to the Lambda function. I have seen some people make mistakes here, thinking that this indicates the number of messages that have been sent to the producers. Like I said, SQS, it's a pool model. It uses a pool model mechanism. So it's the number of messages that have been sent into the queue. If you want to see the number of messages that have been processed by the consumer or received by the consumer, then you need to look at the number of messages received. Where is it? The number of messages received. The number of messages received. So in this case, let's look at the number of messages sent. Let's just click on that for the last 1 hour. So as you can see here, we do have some which one is this? Is this our, yes, so we do have some data points here. However, it's not a lot, and that's because the ones that we just sent recently haven't updated. But you can see here, let's move it to sum, the statistics to sum. So you can see here it's 1 and there it's 1. So this is where you can see if your producers are indeed sending messages to the queue. And also let's look at the number of messages received. Like I said, when a message is pulled or read from the queue, then the number of messages or the number of messages received will then populate, indicating that that message was read from the queue. So if we click on it, you can see that the number of messages received here, it was 2, here it was 2, it was 2, and then it went down. And you can see that it seems to be higher than the number of messages sent at this stage, and that is because the messages were not getting deleted from the queue. If you check on the number of messages deleted, you will see here this message was deleted. Then when we get here, you will see that the number of messages deleted has no data point there because this message was not deleted, because the message was giving us issues. It ended up back into the queue, and eventually it went into the dead letter queue. So these three metrics are very vital when you are monitoring SQS queues with Lambda or with any other consumers, really, because from here you can see how many messages are coming into the queue, and then you can see also how fast your consumer is processing those messages. For example, in this case, if you see that the number of messages are higher than the number of messages deleted, then you can conclude that there are some messages that are not being processed, because ideally after a message is processed, it should be removed from the queue. You can also conclude that maybe the visibility timeout that you have set, it's lower, because what's going to happen, suppose that your visibility timeout is set to 2 seconds. So what's going to happen is that if your Lambda function or any other consumer is still processing that message after 2 seconds, the message will still become available in the queue, and now you might run into an issue where that message is picked up by another consumer. So now you have two consumers processing the same message. So in those cases, you might end up with the number of messages received higher than the number of messages deleted, because only one of those consumers can successfully delete that one message. So these three metrics are very vital when you are working with SQS queues. Another thing I want us to look at here, still on the metrics, that's the number of empty receives. Let's click on the number of empty receives. Basically, the number of empty receives is the number of empty responses. So like I said, when you configure this integration, Lambda sets up workers that are continuously polling the queue. So even when the queue is empty, those pollers are making the receive message API call, looking for new messages. So if there are no messages in the queue, they'll get an empty response, and that will be logged as an empty receive on the SQS side. So you will see that this is constantly high. That's because they are always polling. So now, very important thing to note when you're working with SQS and Lambda is that these can drive up the cost. What happens is, on the SQS side, you basically pay based on the number of messages in the queue. You also pay based on the request that you are making against the queue. So these requests that are being made by Lambda would also contribute into the total cost that you will be charged for SQS for that month. So that's one thing to be mindful of. If you are not using the Lambda anymore, you can disable the trigger so that it doesn't continue polling for new messages from the queue. But yeah, that's one thing to note. We do have other metrics here. We do have, for example, the approximate number of messages visible. This would give you the approximate number of messages that are in the queue. Basically, this is the queue depth. You have the approximate number of messages not visible. This would give you the number of messages that are invisible, that are hidden. So that visibility timeout that we spoke about. So you would see, basically, it gives you an estimated number of messages that are currently being processed. That's another way to think about this one. I'm not going to look at the other metrics, Lambda metrics. So if we let's stop this and go back to our Lambda. Forgot our Lambda function name. Let's copy this and go back to our metrics, and let's go to all. Just paste in our function name, and we can view our metrics by function name. And from here you can look at things such as errors. For example, here you can see that our function was resulting in execution or runtime errors. Again, you can change the graphs here, like the statistics, the period, and stuff like that. So this is also very helpful when you're working with Lambdas. You can check the concurrent executions, basically how many Lambda instances were running in parallel. You can check the invocation. So if you're not getting any messages, or if your function is not running, you can come and confirm if it's being invoked, if you're not getting any logs and stuff like that. You can check the duration also, on average, how long is your Lambda function running per invocation, and also you can look at throttles. So if there are any requests that were not served by the Lambda function because there were no available concurrency, then you can check that here by looking at the throttles. I think we're going to dive deep in the Lambda metrics and also the SQS metrics in our upcoming videos. But for now, basically this is just a highlight. We have covered all the basics. Basically, we created our integration between Lambda and SQS. We looked at the permissions that are required. We looked at the metrics. We looked at the logs, and also we looked at the dead letter queue and how it works. In our upcoming videos, we will dive deep into all those features, but this was basically just an overview of how the two services work together. I hope you liked the video. If you did, please press on that like button and subscribe to the channel so that you don't miss the upcoming videos. And also, please comment with any suggestions or any topics that you would like me to cover in our upcoming videos. Anything that's related to serverless, API gateway, SNS, MQ, or maybe not MQ, but SQS, CloudWatch events, all those services. If there's any specific topic that you'd like me to cover, please feel free to just add that on the comment section, and I'll be happy to dive deep into that. All right, thank you and cheers.